All right, so today we're going to try to tackle a pretty big topic. Um, it's this idea of dark energy,
Oh, yeah.
which physicists came up with to explain why the universe is expanding faster and faster.
Right.
Like we talked about before, it makes up like a huge percentage of the universe.
Yeah, like almost 70%.
But no one actually knows what it is. So it's
Yeah.
like we invented this thing.
It really
Yeah.
is. We added it to the equations and everything, but we're still not really sure what it is or if it's even really there.
Yeah, so it's like we know the universe is expanding too fast, but
Yeah.
instead of figuring out why, we just slapped on this Band-Aid called dark energy.
Hmm.
But what if there's like a totally different explanation? Like something that doesn't need this mysterious force?
Well, there is. It's called the Grand Fibonacci SMF-RVS theory, and it suggests that maybe the universe's acceleration is caused by something called vacuum pressure gradients.
Wait, so you're saying that like empty space, the vacuum, isn't actually empty?
Right, it's not a barren wasteland. It's more like this sea of energy with all these properties we don't totally understand yet. And those properties include pressure.
So you're saying this pressure in the vacuum is what's making the universe expand
Exact.
instead of dark energy.
Yep. No need for this mysterious dark energy.
Okay, so let's go back to 1998, when this whole dark energy thing first came about. Can you remind me what was so groundbreaking about those supernova observations?
Well, astronomers were looking at these Type Ia supernovae. They're these incredibly bright explosions, and we use them kind of like cosmic mile markers. We thought we knew how bright they should be based on how far away they are, but they kept appearing dimmer than we expected.
So it's like the universe was expanding way faster
Oh.
than we thought it should be.
Exactly.
It's like hitting the gas instead of the brakes. And that's when dark energy came in to try and explain it.
Exactly. They needed something to make the math work.
But you mentioned this thing called the cosmological constant problem. What is that?
Well, basically, theory predicts a certain amount of energy should exist in the vacuum, but the amount we observe, as dark energy, it's just vastly different.
So like our calculations are way off,
Mhm.
or something is like canceling out all this predicted energy.
That's pretty much the problem. And on top of that, we still haven't found any direct evidence for dark energy after all these years.
So how does this Grand Fibonacci SMF RVS theory explain the universe's acceleration without dark energy?
Well, it all comes down to these tiny magnetic fields, or SMFs. They're everywhere, all over space. They're super weak, but they just might be the key to this whole thing.
Okay, I'm listening. So we've got these tiny magnetic fields and this pressure in empty space.
Hmm.
How do those two things make the universe expand?
Think of the universe as a giant ocean. But instead of water, it's filled with this vacuum energy. Now, those SMFs, they create these tiny ripples in this ocean, causing areas of higher and lower pressure.
Okay, and that pressure is what's driving the expansion.
Exactly. The higher pressure areas push against the lower pressure areas, and that makes space itself stretch and expand.
So no dark energy, just magnetic fields and the pressure of empty space. I kind of like it. It's a lot more down to earth. But I'm still a little fuzzy on how this theory explains those dimmer supernovae.
Right, well, that's where the Fibonacci scale comes in. This scale describes a pattern in how vacuum pressure changes across vast distances. It's kind of like a fractal.
So you're saying the universe is structured like a giant snowflake.
Yeah, kind of like that.
But how does that affect the supernova observations?
Think about the light from those supernovae traveling billions of light years. As it passes through these different pockets of vacuum pressure, it gets kind of messed with, so the light appears dimmer, even though the supernovae aren't actually farther away.
So it's not that dark energy is pushing the supernovae farther, it's that the light itself is changing as it goes through all this weird vacuum pressure stuff.
Right. And the Fibonacci scale helps us understand how these pressure changes are organized. It shows us how those changes create the dimming pattern we see in the supernovae.
Okay, that makes a lot more sense. So maybe dark energy isn't pushing those supernovae away after all. Maybe it's all just an illusion created by this weird vacuum pressure stuff.
That's what this theory suggests.
It's a pretty wild idea. But I'm starting to see how it all fits together.
It definitely makes you think about things in a new way.
So we've talked about the universe's expansion
Mm.
and the problems with dark energy and this alternative theory. But what about other things we think are caused by gravity, like how light bends around massive objects?
Right, that's where Einstein's theory of general relativity comes in.
Yeah, like how light from a distant star bends as it passes by the sun.
Right.
And Einstein said that's because massive objects warp space-time. So how does this new theory explain that bending without curved space-time?
It goes back to those subtle magnetic fields and vacuum pressure gradients. Light travels through the sea of varying pressure, and as it passes through regions of higher pressure, it gets subtly pushed, changing its direction.
So it's not pulled by the sun's gravity, it's pushed by the pressure around the sun. Whoa, hold on. Are we saying those crazy pictures of galaxies distorted by gravity could actually be caused by this push-based gravity instead of warp space-time?
That's one way to look at it.
Okay, so this is like a completely different understanding of gravity.
It is, but it's exciting.
Yeah, it is. But let's talk about black holes. How does this theory handle those?
It challenges the conventional view of black holes. As these singularities with infinite density where physics breaks down,
Yeah, singularities always kind of freak me out.
instead of a singularity, this theory says that black holes are incredibly dense objects, but not infinitely dense. They're regions where vacuum pressure is extreme. It creates this incredibly strong inward push.
So matter isn't pulled into a bottomless pit. It's pushed towards the center by this intense pressure.
Exactly.
And that pressure is so strong that even light can't escape.
Right.
It's like this theory gets rid of all the infinities.
Yeah, it gives us a way to describe these extreme objects without resorting to concepts that break physics.
I like it. It's a lot more down to earth. So this push-based gravity can explain those huge things, like the universe's expansion and black holes. But what about gravity here on Earth, like how planets orbit the sun?
It affects everything, not just those extreme things.
Really?
Yeah, it affects planets, satellites, even how things fall here on Earth.
Okay, so how does a planet orbit a star without gravity pulling it?
The sun has a strong magnetic field. It creates those variations in vacuum pressure around it. The variations are strongest near the sun and weaker farther away.
So there's like a pressure gradient.
Do that.
So as the Earth orbits the sun, it's constantly being pushed inward by that higher vacuum pressure.
That's the idea.
So the sun isn't pulling the Earth inward, it's the pressure around the Earth pushing it towards the sun.
Pretty much.
Wow, that's trippy. So it's not just a force acting from far away, it's this local interaction with the pressure around the planet.
Right.
And this push-based model can actually predict the orbits of planets.
Just like the traditional model.
That's amazing. So it's not just some crazy idea. It actually has real scientific backing.
That's right.
And it can also explain satellites and how things fall here on Earth.
It can.
This is blowing my mind. It's like this theory is rewriting everything we thought we knew about gravity.
And we're just getting started. There's a lot more to explore, like how this theory might unify gravity with other fundamental forces and what that means for the future of physics.
Okay, now you've really got me hooked. Let's take a quick break, and then we'll dive into those even more mind-blowing implications.
Sounds good to me. Welcome back. So we've been talking about how the SMF-RVS theory basically says that gravity is a push, not a pull. And that push comes from the pressure of the vacuum itself. But it's also influenced by these tiny magnetic fields.
I think I'm starting to get it. Like how this push-based gravity could explain why the universe is expanding faster and faster. But what about other stuff we usually think of as gravity, like how light bends around massive objects? That's where Einstein's theory of general relativity comes in, right?
Yeah. Right. The classic example is how light from a star bends as it passes by the sun, which makes the star appear in a slightly different spot. Einstein explained that by saying massive objects warp space-time, and that creates a dip that light follows.
So how does SMF-RVS explain that without curved spacetime?
It uses those subtle magnetic fields and vacuum pressure gradients. Imagine light traveling through this sea of varying pressure. As it goes through areas of higher pressure, it gets pushed a little bit, and that changes its direction.
So the light isn't being pulled by the sun's gravity, it's being pushed by the pressure around the sun.
Exactly.
Hold on, so are we saying those crazy pictures of galaxies, the ones that are all distorted and magnified, those could be explained by this push-based gravity instead of Einstein's warped spacetime?
Yeah, that's what SMF-RVS suggests. Those distortions might be caused by light traveling through these huge pressure gradients.
Wow. So we're talking about a totally different way of thinking about how gravity works.
It's a pretty big shift. But the cool thing is that it explains these complex things using concepts we can actually measure: magnetic fields and the vacuum.
That's what I like about it. It feels more real, more grounded. But what about black holes? How does push-based gravity explain those?
That's where things get really interesting. This theory says black holes aren't singularities.
You mean those points with infinite density where physics breaks down?
Exactly.
I always thought those were kind of weird.
Well, instead of a singularity, this theory says black holes are super dense objects, but they're not infinitely dense. They're regions where vacuum pressure goes crazy, creating a super strong inward push.
So instead of being pulled into a bottomless pit,
Mm,
matter is pushed towards the center by this pressure.
right. And it's so strong that not even light can escape.
Wow. This theory seems to get rid of a lot of the infinities that mess up traditional physics.
It replaces them with more understandable things like pressure and fields.
I like it. It feels a lot more intuitive. So this push-based gravity can explain the expansion of the universe. It can explain the bending of light, and it can even explain black holes. But does it apply to everyday gravity here on Earth, like how the planets orbit the sun?
It applies everywhere.
Really?
Yeah,
Yeah.
it affects how planets move, how satellites stay in orbit, even how apples fall from trees.
Okay, walk me through that. How does a planet orbit a star without gravity pulling on it?
Remember, the sun has a really strong magnetic field, and that creates those variations in vacuum pressure around it, stronger near the sun and weaker farther away.
So like a pressure gradient.
Yeah,
And as the Earth orbits the sun, it's constantly being pushed inward by that higher vacuum pressure.
right?
So the sun isn't pulling the Earth, the pressure around the Earth is pushing it toward the sun.
That's the idea.
That's crazy.
Yeah.
So gravity isn't some force acting from a distance. It's more like a local interaction with the pressure around the planet.
Exactly.
Can this push-based model actually predict how planets orbit?
Yeah, it's just as accurate as the traditional model of gravity.
That's incredible. It means this theory has real scientific weight.
And it goes beyond just planetary orbits. SMF-RVS can explain the motions of satellites, how objects fall to Earth, even the tiny changes in gravity we measure on different parts of our planet.
It's like this theory could change everything we know about gravity.
From the tiniest scales to the largest structures in the universe.
That's amazing.
And we're just getting started. In the next part, we'll explore some even crazier implications of SMF-RVS, like how it might connect gravity with other forces and what that means for the future of physics.
Oh man, you've really got me on the edge of my seat here. Let's dive right into that.
Okay, so where we left off, we were talking about how SMF-RVS could change our understanding of gravity. And now we're going to get into some even more mind-blowing stuff.
Yeah, like how it might unify gravity with other fundamental forces. That's one of the biggest mysteries in physics, right? Finding one theory that can explain all the forces of nature.
Exactly. And SMF-RVS might just have the answer.
So how does it work? How does it connect gravity with things like electromagnetism and the strong and weak forces?
It all comes back to those tiny magnetic fields and the vacuum.
Okay, remind me how those fit in again?
Well, remember how we said gravity isn't really a separate force? It's more like a side effect of electromagnetism and the vacuum working together?
Right, because those magnetic fields create the pressure gradients in the vacuum.
Exactly. So gravity is like electromagnetism in disguise.
Whoa, hold on. Are you saying that those four fundamental forces might actually be just three, with gravity being part of electromagnetism?
That's one of the things that this theory suggests.
That's huge. If that's true, it means all the forces in nature, from the smallest particles to the largest galaxies, could all be connected by one underlying principle.
That's the idea.
Like the whole universe is a giant web, and gravity is one of the threads holding it all together.
I like that analogy.
But let's get down to Earth for a second. If the theory's right, and gravity is just a side effect of electromagnetism and the vacuum, does that mean we could control gravity someday?
It might be possible. If we can figure out exactly how gravity emerges, then maybe we can learn to manipulate it.
Wow. Imagine the possibilities. New ways to travel, anti-gravity technology, maybe even using the energy of the vacuum itself.
It sounds like science fiction.
It does. But this theory makes it seem almost possible.
It definitely pushes the boundaries of what we thought was possible.
But even beyond the technology, this theory makes us rethink some really big questions, like how did the universe begin? What's going to happen to it in the future? Is there some deeper meaning to all of this?
It gives us a whole new way of looking at the universe.
It makes me realize how much we still don't know, and how many amazing discoveries are still out there waiting to be made.
That's what makes science so exciting.
This deep dive has been incredible. It's challenged me to rethink everything I thought I knew about gravity, and it's given me a whole new appreciation for the mysteries of the universe.
I'm glad to hear that.
Thanks for joining us on this journey. And until next time, keep looking up and keep wondering.
All right, so we've been talking about how SMF-RVS could change how we think about gravity.
Yeah, and how it might even explain those crazy things like black holes and the expansion of the universe.
Exactly. And now we're going to get into some even wilder stuff.
Okay, like what?
Like how this theory could connect gravity to the other fundamental forces. It's like one of the biggest mysteries in physics. Right?
Yeah, like, can we find one theory that explains all the forces of nature?
Exactly. And SMF RVS just might have the answer.
Okay, I'm all ears.
So remember how we've been saying gravity isn't really a separate force?
You mean it's more like an emergent property
Yeah,
coming from electromagnetism of the vacuum?
exactly. It's all connected.
So those tiny magnetic fields and that pressure in the vacuum, they're not just affecting gravity, they're also tied to the other forces like electromagnetism.
Right. It's like gravity is electromagnetism in disguise.
Whoa, hold on. Are you saying those 4 fundamental forces we always talk about might actually be just 3, with gravity being a part of electromagnetism?
That's one of the crazy things this theory suggests.
That's mind-blowing. So all the forces in nature, from like the tiniest particles to those giant galaxies, could all be connected by one single principle.
That's the beauty of it.
It's like the whole universe is this giant web, and gravity is just one of the threads holding it all together.
I like that.
But okay, let's get practical for a second. If this theory is right and gravity is just this side effect, does that mean we could like control gravity someday?
It's definitely a possibility. If we can really understand how gravity emerges from these other forces, then maybe we could learn to manipulate it.
Imagine that. Like new ways to travel through space, or even anti-gravity technology. Maybe we could even tap into the energy of the vacuum itself.
It sounds pretty wild, right?
It does. But this theory makes it seem almost within reach.
It definitely pushes the boundaries of what we thought was possible.
But even beyond the technology, this theory makes us ask some really big questions. Like, how did the universe even begin? And what's going to happen to it billions of years from now? Is there like some deeper meaning to all of this?
It really changes how we see the universe.
It makes me realize how much we still don't know and how many crazy discoveries are still out there.
That's what keeps me going.
This whole deep dive has been incredible. I feel like I need to go back and rethink everything I thought I knew about gravity.
It's a lot to take in.
It is, but it's so exciting. Thanks for taking us on this journey.
Of course.
This is definitely one for the books. So
Yeah.
until next time, keep looking up and keep those questions coming.